Swayam Prabha. Digital India. Educated India.
So you can, so I will, what is that? Who is asking weighted something?
Sir,
Somebody is asking a question.
yes, sir, it's a question given in the assignment. It's based on
Yeah,
weighted
that is
least square
assignment.
equation.
Yeah, weighted least square means the sigma I, it is already there in the question. The first part is the derivation. So
Okay,
it is
sir,
evident, self-evident. Anyway, since you have asked, I will tell you what, which was not considered to be a function of I, and sigma I square equal to sigma square, and then sigma is taken out. That is ordinary least square. If the standard deviation or the variance of the error with every measurement is a function of the measurement itself, then it becomes sigma I. That 1 by sigma I square is Wi. Then it becomes a weighted least square. That's it. Is that okay? Is it okay, Pawan?
No, sir. Can
Hello?
you write on the board? I couldn't get that.
So what is so difficult? There's nothing. It's not so. This was what we did. Okay. Now we said that sigma I square is not a function of. This is equal to sigma. So it become like this. Okay. Then what he did was we removed this and we normalized something. So we just minimize this. Is that okay? Then dou S by dou A equal to 0, dou S by dou B equal to 0. Is that okay? This is how we got the LSR. This much is clear?
Yes, sir. Yes, sir. It's clear.
Now I am saying that there is a sigma I square which cannot be taken out.
Yes, sir.
But which we
Understood.
know, which is not a parameter. Understood?
Yes, sir.
So
Now
this
it's
1
clear.
by sigma I square, I think we have put it as Wi or something. That's, you just read the question. I'm explaining to you the funda. So this is something which changes with I, but is known. A and B are something which don't change with I, but which are not known. They are the parameters. Sigma I is known, but different. Therefore, you have to account for that. So that is the weighted least square. Okay. This some Anand asked one question. What will happen, sir, if the sigma is not the same for all the measurements? Then I said there is a weighted least square. I told you that I will teach weighted least square. But since we are going very slow, I put the weighted least square as an assignment so that anyway you will learn. Is it okay? It's not such a difficult concept. Now that I've explained, it should be easy. Is that okay, Pawan?
Yes, sir. Now it's okay.
Hello?
Yes.
Fine. Okay.
Sir, it's okay.
Now, all right. So now let's go to nonlinear regression. Consider a situation. Consider a situation where the temperature excess theta in a problem, that is T minus T infinity, goes as. So even if you do log of something, 1 by A, whatever you turn yourself upside down, this cannot be linearized, right? This cannot be linearized. Okay, if somebody doesn't believe me, try that. So let's say take a lawn plus since that 1 is there, you cannot put it as, if it is not 1, if it is just e to the power of minus bt, ln of e to the power of minus bt will become minus bt. Now, this you cannot write it as a b e to t. No way. That is can't do this. You can't do this. Okay, some of you will say, no, sir, I got a brain wave. Theta by A equal to 1 minus e to the power of. No, I'll take ln, sir. Please go ahead, sir. Ln theta by A. Now you will say, sir, I can do one more, sir. But please note that the data will be for various values of t. You will get various values of theta. From that, you have to find A and B. How will you get theta by A for starter? A itself is not known. And your y becomes theta by A. A is what you want. Okay. This also does not work. Okay. This is only one. There are many other situations. Please remember, we took a problem last week. There is an aluminum plate which was losing heat by convection. I just lifted it up. It was losing heat by both convection and radiation. Then we said, take it to outer space. Convection is removed. Then there was epsilon sigma t to the power of 4 minus t infinity to the power of 4. Then we said outer space, it's not facing the sun. T infinity is 3 Kelvin. 3 Kelvin can be assumed to be 0 Kelvin. Then it becomes 1 by t, 3t cube, blah, blah. That is a nonlinear form. This is a nonlinear form. Okay. Thermal conductivity is a function of temperature in a simple slab. That will result in a nonlinear form. So the default is nonlinear. The exception is the linear, which we have studied so far. So you must not be under the illusion that y equal to a plus bx and then ln of this thing. So sir taught many techniques. So with a plus bx or y equal to ax plus b or in various avatars, if you know that, if you know linear regression, it's the end of the story. Far from it. Far from it. There are many situations where you have to handle nonlinear regression. And nonlinear regression, because we all believe in the power of maths. We'll add one, subtract one, divide by blah blah blah. Whatever you do, it will not work. So you are stuck here. So you have to proceed from the basic linear regression to some other thing. We'll have to do some other thing now. Some other intervention is required. Therefore, there's a there's a whole new subfield for nonlinear regression which has to be developed. There are many problems which are nonlinear, and this nonlinear regression will be useful in the inverse problem to solve an inverse problem if the form of the temperature or heat flux or whatever varies non-linearly with your parameters of interest. Okay, this is one such case. All right. Therefore, now we have to. So, what is the solution? So, we have to ask that question. So, what is the way out? Okay. So what then is the way out? What then is the way out? Please tell me. What then is the way out? Of course, I will tell you right off the bat that ways are available. So what is the way out? Yes, there are ways out. One simple way. For this problem is to assume AB. These are the initial values. Okay. Now, try to get delta A, delta B using LSR to minimize the error in that iteration. Are you getting that point? So you start with A and B, try to get delta A and delta B. Now A plus delta A and B plus delta B will be the new values of A and B. Proceed to a new values of next set of values of delta A and delta B. Then you will get A2, B2. Each of this you will check whether it is performing well or not. What is the meaning of performing well or not? You will calculate this. Okay. So this one, all right. So this one, if you you will calculate as J plus 1, where J is the iteration counter. Now you have to see. This is S versus J, how it progresses. Okay. For each of these J's, corresponding AB. This is the logic. But from a current value of A and B, how do you get to A plus delta A and A plus delta B? That is the nonlinear regression. Is the philosophy clear to you? So in single shot, you can't solve simultaneously in one stroke. You cannot get A and B. You have to start with some A and B. So you have to start with an iterative technique. So there is no direct analytical solution to the problem. So only an iterative solution is possible. You cannot crack the problem. Just like you say the proof. Because we are so fond of getting analytical solutions, right? That won't work. So you have to start with the word. What then again you will ask what value of A and B to choose. Once this comes, as a student you get jittery, but as an engineer you know what is the value of A and B, because A is some theta I, B is some time constant. So engineering comes into picture. You are the mathematician in you is slightly, it takes a backseat, and the engineer in you takes the prominence. So what should be the likely values of A and B? That comes from your prior knowledge, because of your engineering knowledge, because it is not a damn mathematical problem. It is an engineering problem. Something is heating, something is cooling, a slab is getting heated, there is a tumor. There is some physical situation. Mathematics is only a representation. We should not live and die with by just looking at the form. A form is a way for me to handle. If I can measure everything, I will ditch all this. If there is a way directly I can get A and B in some other way, some other method, I will ditch all the regression, all the probability. Please note that. Mathematics will only serve us. Okay. But the problem I want to solve is an engineering problem. So I'm just using mathematics as a tool. So I started with my tool of Gauss, probability, maximum likelihood estimate, least square regression. Now I have come to a stage where that will not work. Therefore, I have to do something else. Then my original idea of everything can be 3 equations, 3 unknowns, 4 equations, 4 unknowns. My most cherished dream is all gone. It's all shattered. The 3 equation, 3 unknown, 4 equation, 4 unknown, and simultaneously one shot getting A, B, C, D does not work. In this case, getting simultaneously A and B in one shot does not work. Now, if it cannot be solved analytically, does it mean it cannot be solved? Why should it be so? Therefore, we approach it iteratively. I will start with some value of A and B. I will become an engineer. I will start with some A and B and use mathematics to proceed logically. Then whether I'm proceeding in the right direction or not, with every new value of A and B, I will check whether it is converging or not. If it is not converging, what happens? We have tools for that. We'll adjust the rate at which A and B is changing. So for all these things, people have figured out. Again, Gauss and Newton. Gauss was involved in this. So this was the Gauss-Newton algorithm. But anyway, I'm building a case for that. But now let us see how we progress. Okay. So this will, so we will say that this is some epsilon. If S is less than equal to some epsilon, we stop. What do we stop? Stop means what? Stop what? Stop the iterations. Therefore, the Gauss-Newton algorithm has to be executed on a computer. but this is a classroom environment. We are working with paper and pencil. So we will do only simple problems where this can be done using a calculator and paper and pencil. If you are solving a real life problem, the Gauss-Newton algorithm has to be coded. Okay, it has to be coded in R, MATLAB, Python, whatever language you want, Fortran, C++, and then you will have to put your measurements, put your model, and so this is ideal for. It's an ideal case to be coded. Okay, all right. But now,
Sir, why are we giving a power of j plus 1 in S?
j plus 1 minus r.
So the iteration counted.
So I don't
Why
start.
are we set?
I don't understand. Why not? What do you want?
Like, okay, so like, we are like kind of penalizing more as more iteration we do, kind of. Is it?
Not penalizing. What penalizing? I'm evaluating. There's no penalizing. What is a penalizing?
Sir, is that S equal to summation theta I minus theta phi I square whole power j plus 1, right?
Not whole plus at j plus 1.
Okay. Sorry.
Okay. Because the j plus 1 doesn't come for theta I, because theta I is the data. This damn thing doesn't come. It's not worried about iteration. It is a truth. It is a measurement. Is it okay? But this is the estimate. Is it okay?
Okay. Only the index. Sir. Okay.
Yeah, it is the index. It is the counter. It is not the power. I hope it is clear now. All right. Now I've not even come to the algorithm. I am setting out the case. I'm telling you the case why we should move away from linear regression in some cases. Is that okay? So the above steps are repeated till convergence. That is from A, B, we go to A plus delta B, B plus delta B. Then this becomes AB mu. Okay. Then again, A nu plus delta A, B nu plus delta B. Whenever you have this pair, you know what the time is. You'll be able to put it into that original expression and you'll be able to get the S. So you'll keep going like this. So in how many hits you will get this depends on where you start. And whether S will go like this also depends on the nature of the curve, nature of your distribution. Okay. And so there are so many other factors. So you may have to do what is called under relaxation, over relaxation, all that I will tell you a little later. But right now, we have established a case for a nonlinear regression. Okay. Now, the question before us is, how do we solve, how do we reformulate the problem? So that so now, see, before you solve the problem, you have to ask the right question. The right question we are asking here is, how do we then reformulate the original problem, which involved a into 1 minus e to the power of minus bt? Now, for those people who have a doubt where this arises, I will answer that question in tomorrow's class. Okay, where that arises. Okay. The other possibility is to, there are two ways of teaching. I keep telling you, is example first. Today, I'm not using the example first. I'm using the theory first because I thought the mathematics is more important today. Otherwise, I can take a simple case and prove to you that it will result in a into 1 minus e to the power of minus bt, which I thought I will do tomorrow. Is it okay? Last 2 years, I've taught it in the other way. So I will come to the Gauss-Newton regression class, then I will dictate a heat transfer problem. Everybody will solve some half an hour, and then they come to a form which cannot be linearized. Then I will say that now we have a problem where it cannot, linear regression cannot be used. Therefore, you have to use a non-linear regression. But since 2 years, I did it like this, out of fun, just for sheer fun, and also to make it a little interesting or different. I thought today, let's start with something different. Suppose there is a form like this. How will you proceed? Then, where do we get this form? I will answer that question tomorrow. Is that okay? All right. All right. So how do you formulate? Let's do this. So what is the equation number? Where we stopped in today's class? Anybody?
4, sir.
Huh?
4, 4.
4 was gone, or the new one will be 4?
It will be 4.
It will be 4. So that's a clear way of saying it. It will be 4. Very good. So let us rewrite equation 1. Let us rewrite equation 1 in a more general fashion as y equal to a into 1 minus e to the power minus bt. Okay. So I'm putting it as 4 so that because the expansion of y is easier for me rather than theta because it's a general variable. I can also put it as bx so that you are comfortable. Okay. Now yi is f of xi. Please note that f of xi a comma b plus the error of I, correct? So please watch this very carefully. Y of I is the data of, it's a data vector. That is why I can be 1, 2, 3, 4, 5. Why I cannot be 0, right? 1, 2, 3, 4, 5, 6, 7, 8. That is 8 temperatures at 8 times. X is the time here, for example. So once you tell me, once you assume a value of A and B, and then for a particular time, once you have the model, okay, whose parameters we want to determine anyway. But now for an assumed value of A and B, if you provide A and B into this form, and then decide the value of X, for that particular form, you can get the f of X, which is your y fit I. So this is your fit. And since you have assumed some A and B, in general, and there are also errors in the measurement, it will not be both will not agree. Okay, this will be the error. So this error takes care of all the errors. It takes care of the errors in the forward model, errors in the measurement, some error. Okay, this is a difference, some error. Okay. Now, this is the error. This is for the ith point. This is for the ith point. Okay. Now, f of xi, I'm leaving that AB. For the j plus 1th iteration will be equal to f of xi jth iteration plus dou f by dou a delta a plus dou f by dou b delta b plus higher order term. Okay, that is, I'm doing a small expansion. I'm doing a small expansion of f of x. F of x is nothing but this. I'm doing small expansion of f of x around the current iterate of a and b. So if it gently moves through a delta a moves through a delta a and b moves through a delta b. From Taylor series as a function of two variables, I'm using only first order terms. So f of x of I, the j plus 1th iteration. What is the j plus 1th iteration? A b is moving to a plus delta b and b plus delta b. Therefore, it is equal to the current value of the iterate. That is the previous value of the iterate plus the partial f partial a into del a plus partial f partial b into del b plus higher order terms. I can torture it further by having dou squared f by dou a squared del a square by 2 factorial, dou square f by dou b squared del 2 factorial, and then 2 dou f dou b del a del b blah 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 all that. But now I'm saying that it is a small expansion. Therefore, delta a and delta b are reasonably close to the original values of a and b. Therefore, if I put delta a square by 2 factorial and delta b square by 2 factorial, or even delta into delta b will be very small, and therefore higher order terms can be neglected. So I stop with linear terms. So now this is equation 6. Now substituting for x of I, in 5. Substituting for x of 5, we get y of I. So, okay, neglecting higher order terms. Please note, that all the yi's are known a priori. That means we know beforehand because it comes from the set of measurements, and they will not depend on the iteration counter j. Are you getting the point? I is the first point, second point, third point. That is the counter I. J is a b to a new b new a new new a new a b and so on. So the j is the counter of the iteration. How you are mathematically proceeding. I is basically the point. If there are 10 time intervals, I equal to 1 means 10 seconds. I equal to 2 means 20 seconds. I equal to 4 means 80 seconds. J equal to 4 means I start with A and B, and what is the value of A and B at the end of third iteration or fourth iteration? That is fourth iteration is J4. So please remember the difference between it is not the traditional Ij equivalent to XY, what you have done in mathematics. Is it okay? One is the marching in iteration. One is the just the index of the particular measurement. Okay. All right. So the measurements are not a function of the iteration counter. Now I will say yi minus f of xi equals dou f by dou a into delta a plus dou f by b into delta b plus ei. Okay. Now. Watch the arguments very, very carefully. Huh? For all values of I, if I assume a value of a and b, I know the functional form of f of x of I. So for that particular iteration, I know the value of a and b. I know the value of x. I substitute and get the value of f of x of I. I compare it with the measurement, which is y of I. Y of I minus y of xi is the difference. My goal in life is to minimize this. Is that okay? So this is basically, so this now is equal to dou f by dou a into delta a plus dou f by dou b into delta b plus ei. There is a error term. Now, once I assume a value of a and b, okay, I can also calculate dou f by dou b and dou f by dou a. Is it okay? Now this is the error ei. Now the least square regression is what should be the delta a and delta b for that given a and b for that iteration, such that e1, e2, e3, e4, e5. If I add all the, if I have e1, e2, e3 up to e10, e1 square plus e2 square plus e3 square plus blah blah blah, sigma ei I equal to 1 to 10 whole square is minimized. This is nothing but the linear regression problem. So therefore, now by a master stroke, we have converted the nonlinear regression problem into a linear regression problem, not in A and B, but the linear regression problem in delta A and delta B. Therefore, it is incumbent upon us to first assume the values of A and B. Is that okay? Now we have to proceed further. So S equal to sigma I equal to 1 to yi minus f of xi minus dou f by dou a delta a minus dou f by dou b delta b whole square. Okay.
Sir, what about the EI?
What is the EI?
In f of xi, there is an EI term also, right?
No, I'm minimizing that EI whole square, right? No. Now dou s by dou a equal to 0. Dou s by dou delta b equal to 0. Okay. Dou s by dou delta a equal to 2 sigma there is a minus, don't worry about that. So this is the whole square here. Okay. Okay. So what I'm doing is y minus f of x minus all that you take. Keep only the EI. Okay. Sum the EI square. Sum of these squares of EI from I equal to 1 to n. So if you take the dou s by dou delta a, the two times that will come multiplied by this the coefficient multiplying this is dou f by dou a. So if you do dou s by dou b, this 2 times this, the 2 power goes, and then this delta b goes dou f by dou b. Is it okay? Now if you do this, now this is it is a little bit hard, but you will get it. Okay, so it's 12 and 13. Okay, now so this is nothing but so this is your matrix operating on delta A delta B. Okay, I might have made some small minus plus whatever, but general logic is fine. So I am normally Suraj. Please tell me, have I written these equations in the past? Previous batches, no, right?
Yes, sir. This my written, sir.
All the steps I've written.
Yes, sir.
I feel that I am writing for the first time today. Have you shown
First-
all the steps in the previous? Huh?
Yes, sir. First, starting class, sir.
Starting class we have shown. Anyway, if you say it is okay. So please note that we get some scary equations. Of course, now the whole point is if you put it in mathematical form, it is very nice. Okay. So I will put it as, so don't worry about all this. So Z transpose T, Z operating on delta A equal to Z transpose of T operating on D. This is the Gauss-Newton algorithm. Okay, so Z. Okay, so Z is dou F1, dou A, dou Fn by dou A. This is dou F1 by dou B, dou Fn by dou B. Okay, and D, y1 minus f of x1, yn minus f of xn. Okay.
Sir, what is
One
did you
second,
write
Then
the
let me come.
equation? Okay,
What is that? Yeah, tell me.
Equation,
Ah,
equation 15 is
Equation-
not clear.
okay. Yeah, that is Varshini. Yeah,
Yes.
was it Varshini? Is it clear now?
Yes.
So
Yes.
forget about all the math. So even in a dream, you should be able to. Somebody wakes you up. Z transpose T Z operating on delta A equal to Z transpose T operating on D is called the forcing vector. What is the forcing vector? The forcing vector is basically the difference between y fit and f of xi. That is, this is the y fit and the y data. Suppose you attain the perfect solution, what will happen is, if you attain the perfect solution, the forcing vector will become a zero vector, the column of zeros. Once you have a column of zeros, regardless of what is Z transpose Z, whatever, delta A will tend to zero. What is delta A? Delta A is nothing but delta A, delta B. Therefore, as this forcing vector or the error vector reduces, the delta A and delta B will reduce. In the perfect theoretical limit, when the forcing vector becomes zero, delta A and delta B will become zero. Therefore, the iteration will stop. It will never become like that. That is a theoretical possibility, but it is an actual impossibility. Therefore, therefore, what we do is, when do we stop the Gauss-Newton algorithm? Either you can find out the residual is less than epsilon, or A nu minus A old by A nu is less than equal to epsilon. You decide 10 to the power of minus 4, 10 to the power of minus 6, depending on the power of your computer, your patience, how much money you have, what is the time given to you by your boss or this thing, how much time you have for the project or whatever. B nu minus B old by E. No, this is controversial. Okay, we'll put it as old. B old is then epsilon. Nobody will tell you what is epsilon 1, epsilon 2. That comes by experience. It varies from problem to problem. Okay. So what you do is, if it is y equal to a into 1 minus e to the power of minus bt. Okay, have you copied this? Please copy this. So today is the most mathematical of all the classes so far, I think. So it is fun. So this is, of course, Taylor series expansion. Of course, we use calculus, okay, to arrive at a numerical. Calculus is powerful. Calculus is useful. That cannot be denied. But if you're seeking an exact solution to everything, then there may be some trouble. Okay. Now, if all of you are copying, if you are copying, you just be clear and loud. Say we are copying, just give us some time, or we have done. So say something. Done. Varshini says done. I want some 2-3 more hands to go up. Just check up the math. If in between there is some missing step, the general logic is fine because I know it is correct. Okay. But since I'm not recalling from memory, I'm working again and again. So this is the second time I'm working since the morning. Morning I've already worked out. So I'm doing it live. So there could be scope for error. So you just clean it up if there's any mistake. So basically what you do is, so let us say in this problem itself. Okay, in this problem itself, see this theta equal to a into, so we put it in bracket so that you don't get confused. 1 minus e to the power of minus bt. Okay, so dou theta by dou a is 1 minus e to the power of minus bt. Okay, dou theta by dou b is what? Huh?
Minus,
Is it correct? 80, yeah.
minus 80 times e power. Yeah.
Okay. So class, please watch this. So it is painful, but it is one of the most important things which will stand you in good stead, even if you're doing a degree in
Sir,
data
minus
science or
is not
whatever
there.
be your problem.
Sir, minus is not there, sir.
Minus
Plus
is,
80.
yeah, there is a minus.
No, sir. Finally it is plus.
Yeah, because there is a minus here. See, I have done it many times, but there is almost a fatal obsession to make mistakes here. For example, you know what I did? Dou theta by dou b, immediately since a is there, I put a b e to the power of minus bt. If you put it in the exam, everything will come. The variable is b. Therefore, we should put at. Did you notice the mistake I made at the board? How many of you noticed that? Huh? Did you realize what I wrote before this? Because it is not that I didn't learn maths properly or whatever. This a, this a is making me write b. I should not write b. I should write t. Okay, so be alert. Okay, Manthan, you got it. Okay. Now, dou theta by dou is this, Baba. No problem. Okay. Time t equal to 1. Assume you're assuming a value of a, b, assume. If a, b are assumed, theta also is there. A, b are assumed for everyone. So you can calculate f of t1, f of tn. Okay. So you can calculate y1 minus. So this d vector, is given to you. This d vector can be computed. No problem. All right. Now, what about the z vector? Now you are assuming a value of b, so you will substitute t1, t2, t3, t4, t5. You will fill up this column. Is that okay? So this is dou f1 by dou a corresponding to t1. This is dou f1 by dou f2 by dou a corresponding to t2. Last point, dou f8 or 7 or 20 or 100, 200, what have you stuff. So 1 minus e to the power of minus b. So this is done. Then you will come to dou theta by dou b. You do this. Okay. So z transpose. So then this is z. Z transpose tz operating on delta a is z transpose tz. Now, since it is written in a beautiful matrix form, you can use matrix operations, Gauss-Seidel iteration, matrix inversion. So very nice. In the class, you're doing simple problem. A and B, only 2 unknowns. If there are 3 unknowns, there will be 3 by 3 system. You will have to use Gaussian elimination or matrix inversion or Gauss-Seidel iteration and all that. But hopefully, we will stay with 1 and 2 parameters in this course. Okay. I don't know about the NSEM, but 3 parameters will be very unfair. Is it okay? So now we have a way of solving this. So this is basically the Gauss-Newton algorithm. It's a very powerful algorithm. This is a starting point. This is a starting point for all nonlinear regression. It's based on calculus. It's based on simple logic that from okay. So the direction of the movement and how much it goes in the direction of minimization of the least square. So this, but it doesn't mean that once I finish one iteration, I'll get the answer, because it will give you the best with respect to your original assumption of A and B. Then with respect to the current iteration, you go to the new one, till the overall error comes down. Okay. So I think Gauss and Newton, Gauss, he's a high funda guy, so he's able to think about this. Yeah. Okay. In this case, of course, you don't want to use any of this Gauss-Newton Taylor series. You don't want to get anywhere in analytical mathematics. You don't want to go anywhere near calculus. Then what you do is you keep on substituting. You take about 50 values of A. You take about 50 values of B. So you get 2,500 pairs. So for 2,500 pairs of A and B, for this 8 times, calculate the temperature, or for A, B and temperature, A, B and time, you calculate the theta, the temperature excess. So go to machine learning, data science, develop a neural network. Okay. Once you develop a neural network, then if you give in A, B and T, it will return the value of theta. Then for every value of A and B, for that particular set of 8 values of time, find out what the residual is. Then for all the 50 into 52,500 in descending order, you put the residual and then find out which is the, and then out of that 2,500, whatever is the best will be your answer. So this is a neural network or non-calculus first approach. You can just kill it by data, but now there is no need for so much of work in this. It's like taking AK-47 to kill a mosquito. But you may start with 5 or 10 values of A, 5 or 10 values of B. With 100 values, you put a Kuti neural network. That you find out what is the best. That can give you a good starting point for developing a Gauss-Newton algorithm. So what we will do, what we normally do in research, is we start with a neural network and just switch to calculus. Okay, because calculus after something it proceeds very fast. So from the general A and B in the domain space, you don't know where the actual A and B are lying. So instead of following what is called a helter-skelter approach towards determination of A and B, you can use a neural network, data science, whatever is available to you to narrow down your scope. Okay, from original. So let's say you start with some your optimization problem. You start from this. Okay, now you narrow down to this. So to bringing it down to this, you can use your ML, AI, whatever. So and then from here you take from anywhere. Use Gauss-Newton. It will go very fast. There are grandfathers available. There are more and more powerful techniques available compared to Gauss-Newton. It's called the Liebenberg-Marquardt algorithm, LMA, where we put a lambda parameter to this. And I will talk about this in tomorrow's class. Tomorrow's class, we'll complete this derivation, and I'll give you a motivation for a heat transfer problem. I'll give you 2 simple examples where A theta equal to A into 1 minus e to the power of minus bt comes, and then Suraj will show you a sheet which contains a problem, and then that problem will tomorrow on Wednesday's class we should be able to complete it 2 iterations at least, so that I want you to do hand calculation for at least 1 problem in the class. So please bring your calculator, be ready for some calculations tomorrow and day after tomorrow. So please check the derivation. Okay, I think it should be fine. Otherwise you can check the video recording. If there is any problem, please let me know. Okay, so how was the quiz? I already spoke. I talked about it. See, next time onwards, if there is any issue and all that, please don't send me email. It's not that, because there's a good chance that I may miss it. Okay. Since it is related to the course and there are 2 TAs to the course, please write to the TA with a copy to me. Otherwise, you are making me do extra work. So I have to again copy to the TA and this thing. And so you will first check for duplicate submission and this thing, whether it is genuine or not or whatever. Anyway, okay. So don't just say something, a PDF, sir, please find a PDF or something. So don't do that. So it's quite possible. I have some 31,300 unread emails in my inbox. It is over the last so many years. Okay. So it's quite possible that I can miss it. Okay. So don't engage me with you can engage me with email, but If it is related to the course, please mark the TA so that in your own interest. So at least if I forget, Rajesh will say, sir, some student has written something. What is it? He will check with me and then we will give a response. Okay. For your safety, always write to the TA with a copy to me. That's a better practice. And then next time onwards, don't say that the internet is not working, that is not working. You can't say that for a JE exam or NEET exam or after the Indigo flight has taken off. Whatever reason you are giving, the flight has taken off. Can you do this for a US visa interview? So yeah, let's this thing, 1 or 2 cases, there may be genuine cases. So next quiz onward, particularly those people who have had trouble, you should fix it. Regardless of whatever this thing, we should make it work. Next time, I don't want the same set of students say, I have internet. You have internet issue, so you fix it now. Next time, you should not have that issue. Okay, that is the way we progress. All right. So we will evaluate it, and next week we'll give you the mark. So tomorrow we'll proceed with the GNA. Okay. So thank you all.